Hi, I'm Daniel Stoller, and for my junior design project 3, I made a 3D model of an IMU, which includes a gyroscope and an accelerometer, and displayed it in a 3D model. And then I turned that into a 3D color matching game. So, in order to play this game, first you have to start this Arduino code, which will print the angles for the pitch and the roll of your IMU. It does this through a Kalman filter, and which takes your accelerometer and gyroscope values and turns it into an angle. Um, so now that's uploaded. We go to our code. Um, we start the game. So we're on COM14, and this is our baud rate. And you can choose between 5 different difficulties. Little administrator secret, if you don't click on any difficulty, this will show you the 3D model. So this is the pitch and the roll. See how when I move it in real life, it also moves on the screen, and you can see the pitch and the roll values. And if I keep it still, it stays still. So we're going to go through the tutorial, which is difficulty T. How to play 3D color match. Match the color of the front of the board to the color of the background by removing or adding red, green, and blue. Let's get started. So in this mode, it will show you what orientations do what actions. On the bottom left, you have your red, green, and blue values. Currently, it's gray, which is red 5, green 5, blue 5. And then the bottom right is your answer key. So let's start making it towards the answer key. So as you can see, different actions and orientations cause different colors on the screen. So we want to remove red. So we want to find the red, and it says remove red on the bottom left. So boom, now 2 red is removed and we have turquoise. So we want to remove 3 green. So let's remove 1, 2, 3. And then we want to remove 1 blue. So we'll go 1, score 1. Some other features. If you go all the way to the right or all the way to the left, it'll increase or decrease R, G, and B all by 1. So we see that this color is very bright. So let's brighten our current color. So we'll just keep it all the way to the right. And then add more red. And that's basically how you play the game. Difficulty 1 is a little different in that you are given an error, and an error is the amount, like how far away you are from the current answer. So we're 8 away, which means that we need to make 8 different changes in order to get this color. So let's add more green. I calibrated this badly. Let's take away some red. Take away some. Yeah, okay. Update in 1. Okay, and now it's updated. Our errors get updated every 10 seconds according to the update on the right. So we're 4 away. So let's move R, move B. How far away are we? We're 2 away. So let's increase G by 1 and decrease B by 1. Still 2 away. There we go. Score 1. And then we're given a brand new color. For difficulty 2, this is the regular mode, given R, G, and B, and elapsed time, no help, and nothing making it harder for people. So you can't lose in this mode. Mode 3 is the first one where you're able to lose. So right here, you have a timer. You have 60 seconds to get this. So if you add B, make this brighter. Let's take out some red. Make it brighter. Green. We got some blue. We're almost there. Got blue. Boom. And then we have a rollover time of 40 seconds. That means we only use 20 seconds. And on those 40 seconds rolls over to the next round. And I can use it. Now, if it started at 100, if the timer were to go down to 40, I would have no rollover seconds because it just uses the 60 seconds allotted timer first, and then it'll use your rollover time after. So you had no extra regular time. And now finally for the final difficulty, this one is not only the timer, but also moves left. So you only have 30 moves. So anytime you change anything, the moves goes down. Darkening and brightening counts as one move, even though it changes all three values altogether. So that is the majority of the project. Just to go into some nitty-gritty about the details. This prints into the serial monitor the pitch and the roll. If I turn this way, the pitch increases, roll increases, roll decreases. And so these values get read using PySerial. And so we take the values, we extract the pitch and the roll, and then we rotate OpenGL based on that. So how OpenGL works is it creates a 3D world and it moves and rotates that 3D world around you based on the pitch and the roll. So that's how that works. So like every single we're in position 0, 0, -5. So like we're a little bit away. And then every single time that the pitch and the roll changes, we rotate the entire world around that. So we can see what's happening. And so even though it looks like this is what's moving, it's actually the entire world that is moving. This class called background holds the score, the background, the moves, the timer. This is like everything about the game, and it has different functions for the game. Color factor, that's your current color of your board, and it's in charge of changing it and when to change it, how long you need to be in a certain zone before it changes, where the certain zones are. Run application does the settings window. Initialize PyGame opens up like the window for OpenGL. Initialize OpenGL does the background, and then DrawGL does like the text and the board, and it's constantly updating. In the main, we initialize everything, make sure that the serial connection is good so that we're writing well. And then within this main loop for while true, we are constantly drawing GL, and then we wait 10 seconds. So we are constantly drawing the world, and every single time there's a change, we change along with it. So the maximum change would be like very slow. So like we're like printing like that. So how it knows if you win or lose is if you compare the background and it returns true, aka your current color is the background. Or if you press escape, that's like an easier way of winning. That's just like for testing and stuff though. Then you add one to the score and you say your score and you roll over time if that's what your difficulty is, or allows. And then you get a brand new one. So you initialize a new GL. So like you initialize a new background and you restart. Now, if either you run out of moves and your difficulty is 5, or you check the timer and it's 0 and your difficulty was 4 or 5, then you say that you lost and you say your final score. And that statement was also no, actually it wasn't. Yeah, this just says your score. So that's the majority. That's the majority of the code. To figure out or to test this code, I had my entire family test out the game, see what worked, see what didn't, make changes based off it. And it seemed pretty user friendly, which is good. And that was the point. I've had a lot of fun playing it. I've gotten really good, as you can see from my record times. But yeah, that's my project.